Zeolites are really fascinating, beautiful, and incredibly useful materials. They're actually used to make all of the high-octane gasoline that we use in the world, the millions and billions of gallons. Zeolites have shown great promise in being able to make biofuels. We discover the structures through a method where we shine light on zeolites, and we figure out the light that actually bounces back. And that's a fingerprint of the structure. And then by doing modeling with quantum mechanics, we're able to put the pieces together. It gives us a way to see the dance that atoms do when they're actually forming this crystal. These fundamental building blocks are the ones that are doing the work. All zeolites have pores, and in these pores, or these cavities, is where the chemistry happens, where molecules get changed. One of the fascinating questions about zeolites that we don't have the answer to right now is actually how they form. So we're always looking for new zeolites, better zeolites, but in order to do that, we need to know how zeolites form, and that's why this research is so important. This is exciting because we now have a new technique that's going to allow us to actually make new materials, new zeolites, that can do things like capture carbon dioxide.